In the last video, we managed to solve a system of linear equations using Gauss-Jordan elimination, but I sort of led the way in the sense that you maybe didn't know why we did the steps we did and why the order we did them in. So we're building up to get to the procedure for Gauss-Jordan elimination so that we understand why we're doing each of the steps we're doing and when. But before we do that, we need this idea of pivoting. Okay, so each of the steps can be complicated to explain. So we want this term pivoting, we want to understand what that means to make it a bit simpler. So what does it mean to pivot? So given a matrix and a non-zero entry, okay, it's important that the entry is not zero, we can pivot around this entry by make the entry a 1. Okay, so to do that, what we can do is divide the pivot row, so that's the row that the pivot element is in, okay, by the pivot entry. Okay, so we have to do this to the whole row. So this is also the same thing as multiply by 1 over the pivot entry. So remember, one of our allowable operations is to multiply or divide by a non-zero number. So that's why it's important that the pivot is not 0, so that we can do this step. So you make it a 1, and then what you want to do is make all the other entries in the same column to it as zeros. So the way that we do that is by adding or subtracting multiples of other rows. Okay, now normally we use the pivot row. Because it's a 1, it makes these multiples a bit easier to come up with. But again, you don't have to do that. So you add or subtract multiples of other rows to the row with the entry you want to make 0. So we're going to do a couple of examples, practicing pivoting, just to get the hang of it. So we're going to pivot around the circled entries in the following matrices. So now, just to be clear, if you have done Gauss-Jordan elimination before, we are not trying to solve the system. Okay, we're just pivoting around this entry. So this entry might not make sense to start with if we were actually doing Gauss-Jordan elimination. Okay, but we're just practicing the idea of pivoting. So we have this matrix and we want to pivot around this 5. Okay, that's in row 1, column 2. So what we want to do is we want to make that entry a 1. Okay, so we want to make that a 1. So the way that we do that is to divide the row by the pivot entry. So I'm going to call this row 1 and row 2. Okay, so that we can refer to it. So what we're going to do is we're going to do row 1 divided by 5. Or if you want, 1/5 of row 1. Okay, so we take row 1 and we divide everything by 5. Okay, and we leave row 2 alone. So we haven't done anything to row 2 yet. So I'm just going to simplify. So 15 over 5 is 3. 5 over 5 is 1. Okay, that's what we wanted to be in that spot. And 20 over 5 is a 4. Okay, so our new row 1 is 3, 1, and then 4. Okay, we're still pivoting around this entry. So we're not done. We made it a 1. Okay, now we want to make the thing below it a 0. So to do that, we want to add or subtract multiples of other rows. So what you want to do is look in the same column. Okay, now this is easy because there's only one other row, and it happens to be the exact same number as the one we want to get rid of. So our next step is going to be, so row 2, the new row 2 is going to be the old row 2 minus row 1. Or if you want, so the old textbook used to always use plus. Okay, so it would be -1 times row 1. I prefer when it's a minus we need to multiply by to just do a subtract, but it's up to you. Now, the notation here I want to talk about a little bit for these operations. So you can write the new row 2 is this is what it's equal to sort of emphasize that you're changing row 2 here. I normally don't do that because I normally just write the row that I'm changing first. Okay, so this is the row I'm changing, and this is how I'm changing it. So I'm going to subtract row 1 or add -1 of row 1. So we're not changing row 1, so we can write that row in exactly as it was. We're only changing row 2. Okay, now in the first spot, we have our old entry, -3, and I want to subtract the entry in row 1 that's the same column. So I'm going to have -3 minus 3, so I'm going to get -6 in this spot. Okay, in the next spot, I had a 1, and now I want to subtract the 1 that's above it, so I now have a 0, which is what I wanted in that spot. Okay, and the last one I had a -9, and I want to subtract 4, so now I'm going to have a -13 there. Just to emphasize this, okay, so these first things are from the row 1, okay, and then the second things, what we're doing is subtracting, those are from the column, or the row 1, okay, and the first ones are from row 2. So you take the entry in row 2 and you subtract the entry in row 1, or you add -1 times the entry of row 1, and you're always doing it column wise because those are where the like terms are. Okay, so now at this point we're done pivoting. Okay, so our pivot spot has a 1, and everything else in that column, the only other thing, is a 0. Okay, so that's how we know that we're finished pivoting. So let's try another one. Okay, so here I want to pivot around this -2 entry here in row 3, column 2. Okay, so my first step is going to be -1/2 of row 3. Or again, row 3 over -2. Okay, whatever you prefer. So row 1 and row 2 stay the same. So I'm not changing those, I'm only changing row 3. So what I'm going to do is divide everything by -2. So 6 over -2 is -3. -2 over -2 is a 1, that's what we wanted. And -4 over -2 is a +2. Okay, so we're still pivoting around that entry. So we're not done, because now, so we first, okay, make this a 1. Okay, now we want to make each of the things above it a 0. So let's do the top one first. Okay, so I'm going to make row 1, the 1 in row 1, I'm going to make that a 0. So I want to change row 3, or sorry, row 1. I already changed row 3. I want to change row 1, and I want to do it, because I want to make it a 0, I want to use another row to do it. So I look in this column, okay, and the pivot thing is actually the easiest thing to use. If I wanted to use row 2, I'd have to divide it by 4 so that I get a 1 here. So let's use this, and it's usually better, especially when you're just learning, to use the pivot row. Because it's a 1, it's always easy to use. So I'm going to take this row and subtract this row from it, so that in this column I'm going to have 1 minus 1, and then I'm going to get a 0. So I'm going to do row 1 minus row 3 in this step. Okay, now row 2 isn't changing. So you could write it exactly as it was. Row 3 also isn't changing. So again, you could write it as it was. So now in row 1, I'm going to take the old entry from row 1 and subtract the entry in the same column, but from row 3. So here I'm going to do -2 minus -3. So that's actually -2 plus 3. So I'm going to get a 1 there. Okay, now in the next spot, I used to have a 1, and I'm subtracting the 1 from row 3. So I have a 0, which is what I wanted. Now in this last spot, I had a -1, and I'm subtracting the 2 that's in row 3 in the same column. So I'm going to end up with a -3 there. Oops. Okay, so that's a -3. Now we're not done pivoting. Okay, so we're still pivoting around this value. So my next step would be to make this 4 a 0. Because remember, we want everything else in this column to be a 0. So we made the 1, we made this a 0, now it's this one's turn. So that means that I need to change row 2. So I'm going to write that first. How I'm going to change row 2 is using this 1 down here. So what I want to do is subtract 4 times row 1. So if I multiply this row by 4, this number is going to be a 4. So then I'm going to end up with 4 minus 4, which is going to give me the 0 that I want. Okay, so that's what we're doing. So row 1 stays the same. Row 3 stays the same. So we're only changing row 2. So in the first spot, I used to have a 0, and I'm going to subtract 4 times my -3 number. Okay, maybe I just want to illustrate this a bit. So, okay, so the 0 is from here, and the -3 is from here. Okay, so notice they're in the same column. So 0 minus -12 is going to be +12. Okay, now in the next spot, I used to have a 4, but then I subtract 4 times the 1 that is there. So again, the 4 is from there, and the 1 is from the thing below it. Okay, this is what I wanted to happen. Okay, 4 minus 4, I get a 0. Okay, so that's exactly what we wanted. Now in this last spot, I used to have a 1, but now I'm going to subtract 4 times the 2 in the spot below. So that's 1 minus 8, so this is going to be -7. Okay, now if we look at this pivot column, okay, there's a 1 in our pivot spot and 0s everywhere else. So now we are done pivoting. So when you perform Gauss-Jordan elimination, what you're going to do is you're going to first represent your system. Represent your system with an augmented matrix. Okay, and then we're going to pivot around certain entries. Okay, so we're going to be using this pivot quite a lot. So we're going to pivot around these entries using only the 3 operations that were allowed. And we're going to want to transform the matrix into what we call diagonal form. Okay, now around certain entries. Okay, so that might be confusing. So we'll see how to choose these entries. Okay, later. But we want the matrix in diagonal form. So what that means, if you had just 2 equations and 2 variables, you want the end result to look something like this. Okay, so there's 1s along this, we call it the main diagonal, and 0s everywhere else. And then these are just numbers. Okay, they can be the same or different, doesn't matter. So you might say, okay, well, it looks like I pivoted here. because I made it a 1 and I made everything else a 0. And then I also pivoted here because I made it a 1 and I made everything else a 0 in that column. And that's exactly what we're doing. So if you have 3 equations with 3 variables, it's going to look similar but bigger. So something like this. So again, the 1s are on the main diagonal, and each column has the 1 on the diagonal and 0s everywhere else. Okay, so that again means we pivoted here, we pivoted here, and we pivoted here. And we're actually going to do it in that order. Okay, so that's sort of how the Gauss-Jordan elimination method is going to work when it works in the ideal scenario. Okay, so that's where we're going. Once we have this diagonal form, then we can read the solution. Because remember, this is going to be like the x variable, the y variable, and the z variable, those columns. Maybe I should call these so we can tell the difference. So if we turn back into equations, this is going to be x equals star 1, y equals star 2, and z equals star 3. So that's going to give us the solution to our system. Okay, because so let's say this one is because these ones are 0, that means there's no y and no z, because the coefficient in front of them is 0. So that's why I get x is equal to this number. Okay, so this is why it helps us. And when we use only the allowable operations, that guarantees that the solution stays the same the whole way along. So we never change the solution.